Hello and welcome to the Data Engineering Podcast, the show about modern data management. Data lakes are notoriously complex. For data engineers who battle to build and scale high-quality data workflows on the data lake, Starburst powers petabyte-scale SQL analytics fast, at a fraction of the cost of traditional methods, so that you can meet all of your data needs, ranging from AI to data applications to complete analytics. Trusted by teams of all sizes, including Comcast and DoorDash, Starburst is a data lake analytics platform that delivers the adaptability and flexibility a lakehouse ecosystem promises. And Starburst does all of this on an open architecture, with first-class support for Apache Iceberg, Delta Lake, and Hoodie, so you always maintain ownership of your data. Want to see Starburst in action? Go to dataengineeringpodcast.com/starburst and get $500 in credits to try Starburst Galaxy today, the easiest and fastest way to get started using Trino. Dagster offers a new approach to building and running data platforms and data pipelines. It is an open-source, cloud-native orchestrator for the whole development lifecycle, with integrated lineage and observability, a declarative programming model, and best-in-class testability. Your team can get up and running in minutes thanks to Dagster Cloud, an enterprise-class hosted solution that offers serverless and hybrid deployments, enhanced security, and on-demand ephemeral test deployments. Go to dataengineeringpodcast.com/Dagster today to get started, and your first 30 days are free. Your host is Tobias Macey, and today I'm interviewing Andy Jefferson about how to solve the problem of data sharing. Can you start by introducing yourself?
Yeah, hi Tobias. I'm Andy. I'm the CTO at Bobsled. We're a Series A startup solving the problem of data sharing for enterprises in the cloud.
And do you remember how you first got started working in data?
For me, software engineering has always kind of been about moving and processing data, whether it's getting a tweet or an iMessage from my phone onto your phone, or whether it's control software in a power plant or a chemical plant that's taking input data from sensors and things, and then processing that data, and then creating output data that are signals to control software, pumps, and things like that. But I got started relatively late during my PhD. I was doing a PhD in chemical engineering, and I started with work on control software. And one thing that I really enjoyed about that was that you actually wrote software that did something very tangible and real in the real world. And from that, I got into computer modeling during my PhD. And then a little later, I actually quit my PhD to join a software startup because I found I was enjoying the software engineering more than I was enjoying the welding together of tons of stainless steel. And then from there, my first job was as a database administrator on a SQL Server, Microsoft SQL Server as it was then. So my very first job in software engineering was in the data realm. There in a lot of administration. I got first-hand experience of the move from on-prem to cloud. So that was back in the day when, I remember when Microsoft SQL Server on Azure was first launched, and then testing out and being really excited about no longer having SQL servers that initially sat next to me and then later were in a data warehouse. But I used to go and visit them, and I got the chance to see that transition into the cloud and really understand the benefits of no longer having to kind of babysit physical boxes and the things that can go wrong with them, and doing the upgrade and all that kind of stuff. And from there I've had what I think is a pretty exciting and fun career so far, moving through different kinds of things. So from there I moved into a company that was doing an OLAP database built on top of Cassandra at the time when NoSQL was a big thing. So NoSQL databases were the new hot thing. OLAP was very fashionable. And it was a company called Akunu who were building an OLAP solution on top of Cassandra. And we worked with some large ride-sharing firms and things there. So I got a chance to see some of the power of big data and things you could do, at a real scale as well. And from Akunu, I went to Apple iCloud. So I got my first experience doing data sharing in consumer data sharing. So at iCloud, I was working on some of the kind of protocols and database stuff that was related to how you share, not just between devices, right? So iCloud synchronizing things like photos and app data between different Apple devices. But we also worked on the first protocols for doing sharing, where you could do stuff like share photos to another iCloud user. That's pretty awesome. We also did some big data processing work there, where we were doing stuff like reference counting at scale. So when you're sharing things, you need to keep track of how many people have shared it. And if all of the people who've shared it have deleted it, then you can garbage collect it and things. We were doing that with very large Hadoop jobs. as that was like the thing that was of its time. Sure, it would probably be Spark today. After working at Apple, I went on to work at Neo4j. Right, so I went to work on a company called Tractable, where we were building an AI solution, and there I was working on building data infrastructure again for training deep neural networks to do computer vision. And after that, I worked at Neo4j, which is a graph database. So my career has spanned quite a range of kind of databases and data technologies. At Neo4j, I worked on on both the database as a service product, so managing Neo4j clusters as a service for users, and on the clustering algorithms, doing things like the Raft implementation and working on scaling the distributed systems algorithms for Neo4j, so you could scale up your clusters to like thousands of nodes if you wanted to do kind of big data graph processing. So yeah, quite a range of graph technologies. And it's actually at Neo4j where I met Jake, who's my co-founder at Bobsled.
And now, for the context of this conversation, I'm wondering if you can start by giving some scope and framing around what we mean when we say data sharing, because that can mean any number of a broad variety of things. And I'm wondering if we can just kind of give the proper framing for what we want to discuss during the rest of this conversation.
I think we've been sharing data for years. As I talked about, consumers have been sharing data for a long time. And even if you think about things like a tweet as a form of data sharing, you write some data and then you share it with the world on Twitter. And businesses have been doing this for years. You can go way back to businesses that used to post sets of data around on CDs. Again, thinking back to my very first role, I was in the UK, in London, and we used to get a CD from a company like the post office, US equivalent would be like USPS or someone, which had like all the zip codes and mapping of all the zip codes into kind of addresses and regions, right? And that used to be something that people provided on a CD, and you signed up and you paid money and it got delivered to you in the mail. And so data sharing between organizations has been going on for years in lots of ways, say from CDs in the mail through to APIs, different kind of cloud-based sharing techniques, right? A lot of people use APIs as a way of, in inverted commas, sharing data, right? It's like, I have data, and if you call my API, I tell you, tell about some of the data I have, we're sharing that data and then you're doing something with it. And for this conversation, we're concerned with data sharing between businesses and data that's being shared really for the purpose of analytics, about our kind of OLTP versus OLAP. We're thinking about, you have a fairly large amount of data that you're sharing with someone else so that they can use that data in their analytics. And the typical usage will involve things like joining that data to other data that the recipient has, and then doing analysis on that. It's pretty rare that someone just says, hey, give me some data and I'm going to analyze it in isolation. You can think of some things like in the financial world where maybe you say, give me all of the stock ticker data and I'm just going to analyze it in isolation and then try and use that to make predictions about what stock prices will be. But in reality, even that use case is quite rare, and most other use cases you're saying, let's share data between our two enterprises, and then each of us, it might be one way or two way, but the recipient is then going to join that data with some stuff they have or use it in their own applications. But it is a broad scope. Really, it's any analytics data moving between organizations.
And so, given that context of I at organization A want to be able to send data to organization B, or I need to be able to request data from organization B to use for purposes of some sort of partnership agreement or whatever the case might be, what is the current state of the art and state of the ecosystem for being able to enable data sharing across organizational boundaries, whether that is separate businesses or just different business units within an enterprise, and some of the complexities that arise because of that current state of the ecosystem?
Yeah, it's a really good call out. Like, we do see a lot of internal organization data sharing as well. We speak to a number of people who have problems, particularly in larger organizations, either with geography or where they've done things like acquire different business units who have different platforms and things. Yeah, it's great class. But what's the current state of the art? So I started off talking about kind of sending CDs in the mail. The kind of follow-on technology from that really is FTP, SFTP, and sharing CSVs. And we see this as actually the dominant mechanism today where data is shared between organizations. So someone maintains an FTP server, they put CSV files on it, There's usually some dance involving sharing RSA certificates so that you can SSH connect to someone's FTP server, and then you can read the data off it. And FTP can operate in a push or a pull orientation, so you could push data onto my FTP server, or I could pull data from your FTP server. That's really the dominant thing. I think some of the shortcomings of that are kind of obvious, particularly as businesses and everyone moves into cloud native kind of environments. But that's the thing we see a lot. Then the follow on from that is really kind of data APIs. This I think of as kind of CSV via HTTP. It's not radically different from CSV on FTP, but there are various APIs that we can see in the world, particularly common with things like SaaS businesses. You make an API call, often with some query parameters, which is just necessary because you can't pack that much data into a single HTTP request. And so you say, hey, give me some data. Here are some parameters that scope it down to a reasonably small chunk. And I make an API call and you return that data. And it's often, again, ultimately kind of CSV or JSON formatted. In some scenarios, it's you make an API call and you kind of get back a Parquet file or something. But that's less common. I talked a bit about the limitations of that. It's just really not something that HTTP is built for. And there is a cottage industry of home-built tools that people have for kind of scraping these APIs and then reconstructing complete tables via lots and lots of queries, things like that. And that was really, I think, based on a lot of people who were kind of saying, we have a hammer. So, the hammer that people had is like REST API and JSON that serves JSON data. And they kind of just took that hammer and applied it to sharing analytics data. Then, the major state of the art, I'd say at the moment, is connectors. Right? So there are companies like Fivetran and Stitch and others who provide what's kind of connector things, either as a service or as software or open source software that you can use and run yourself. And that broadly helps you to, as a consumer of data, to pull in data that is shared with you from kind of a range of different sources. So connectors can connect to the data API, they can connect to things like FTP, and they're based on a kind of pull principle. So it's the consumer of the data takes responsibility and they use it for getting hold of the data that's been shared to them, and they are moving the bytes using a connector and then putting it somewhere, whether it's like file storage or a data warehouse. And connectors in an ecosystem where there's lots of data sharing and things like that are inherently quite resource inefficient, right? Because every consumer has their own connector running, has their own copy of the data. So there's kind of inefficiency and there's a latency and there's a lot of duplicated compute with lots of different people making the same API requests to pull the same data into different places. It puts a responsibility on the consumer of the data to kind of operate and maintain and run this system. And then there is in place kind of cloud native sharing, right? Pretty much every major data platform or cloud platform offers that today. So whether it's something like S3, which has a feature called access points, which is particularly designed for sharing data between S3 buckets, whether it's Snowflake sharing, BigQuery sharing through Analytics Hub, Databricks has Delta sharing, Azure has Azure data sharing. All the platforms offer these things, and they do what we call in-place sharing, which the key thing of in-place sharing is the data isn't duplicated. So you immediately get a huge efficiency bonus, particularly as you start to share the same data or same parts of data to different users. And on the data warehouses, they allow you to share the data you have kind of exactly as you see it. So you can share tables, you can share not just the data, but things like the foreign key constraints and the indexes and the views and all that stuff. So it's really rich as well as more efficient and more straightforward. When we talk through all these things, what it shows us is that this data sharing isn't just a purely technical concern. A huge amount is tied up in the kind of business socio-technical arrangement, right? Where we're like, when we share data, who takes responsibility for what, right? Who takes responsibility for paying the compute costs? Who takes responsibility for maintaining the structure of the data and the indexes and the foreign key constraints and things like that? And that's all tied up in an approach. So when I talk about connectors, there's an implicit expectation that this is a pull-based thing, that the consumer of the data will be paying for a lot of the compute and stuff that happens. If we talk about a push FTP, that's a reversed expectation on who has responsibility for things, because the consumer maintains an FTP server, but the provider pushes the data into it. And that's also true with in-place sharing. And yeah, we think that in-place sharing provides some of the best splits of these responsibilities. Right? It allows things like the person who's analyzing and running compute on the data pays for the compute, but the person generally who's providing data is paying for things like the storage. And it works incredibly well for people in terms of ease of use because we basically eliminate ETL. Right? If I just say, here's my table in Snowflake, I'd like to share it to you, that's it. There is no ETL compute process or anything else. You can just start analyzing straight away. So yeah, that's really the current state of.
And in terms of those socio-technical elements of data sharing and the methods and motivations behind it, one of the other complexities also comes into the compliance question, where as the providing organization, I need to make sure that I am eliding or masking certain pieces of information because I can't share it externally, or I need to ensure that there are appropriate controls on that data as it is being shared so that it is not accessible by some man in the middle or a third party that is not supposed to be involved in this sharing. And then there are also questions of public data sharing, where I, as an organization, want to be able to create and publish a public data set that anybody can use, but I don't want to have to pay millions of dollars because somebody else is using all of my compute to do analysis. And I'm wondering if you can talk to some of the ways that those considerations factor into when and how businesses decide that they actually want to engage in these data sharing agreements, and some of the ways that those considerations will maybe prevent what would otherwise be an amenable relationship.
Yeah, so two things that I think come out here: the compliance and privacy and sensitivity management has some strong technical aspects. It's also good to think about like the breadth that we see in data sharing kind of arrangements. So we see a real range from things like supplier-consumer relationships in manufacturing, where the kinds of data that's being shared is stuff like how much stock does a manufacturer who's providing parts to an assembler like have. So we see this in things like the automotive industry, where the automotive buying organization has huge power, and they actually have arrangements with their providers where they say, hey, you've got to tell us like how much stock you have and how many parts you have on the shelf so we can manage our supply chain risk and things like that. And that's kind of sensitive commercial information that they want to keep between themselves, but it's also not subject to the kind of compliance that you might see at the other end of the scale when you get into things like healthcare data and things that's covered by HIPAA, and say a health insurance company in the United States that wants to share data with a pharmacy company or a hospital organization. And that's a very different concern. In the with healthcare data, you start to have concerns not just of like what data is accessible, how is the access to that data audited and tracked. And in Europe, you also have things like right to be forgotten, where you want to say maybe you don't need to track who's accessed data, but you need to have a way to redact data. And doing in-place sharing, getting onto the technical side of these requirements, in-place sharing helps with quite a lot of them because the cloud platforms provide some things that allow you to do things like audit who's read the data. And if you remove data from an in-place share, it's gone. Whereas if someone's copied your CSV files over to somewhere else, then you absolutely need to have more processes in place. But a lot of this comes down to the kind of relationships, contractually between organizations as well. So organizations have to make sure they've got the right legal things and the right compliance in place before they can do data sharing based on their industry and the kind of data they want to share. Yeah, does that answer the question on that?
Yeah, and digging more into the mechanical aspects of data sharing, as you mentioned, there are a few different ways to think about it, where one is I have this data, I am going to extract it from the system that I use to maintain it, I'm going to push it into some other system, whether that's S3 or FTP. You can take it, do whatever it is you want with it. I have no more visibility or control over that data. Versus on the other end of the spectrum, you have the Snowflake and BigQuery approach of I have this table, I'm going to make it available to you. As long as you have an account with that same provider, you can query it, do whatever you want, and I have some level of visibility of how it's being utilized. But I also still don't maintain control over it once you use it because maybe you're extracting it elsewhere. And I'm wondering if you can talk to what are maybe some of the shortcomings of even that more sophisticated approach of the sharing the entire table and its context and history, and some of the technical capabilities that need to be present for the data sharing solution to be effective, whatever effective might mean given the context?
Yeah, particularly around kind of sensitive data and things of that nature. It is a business socio-technical area, so some of it comes down to just the contractual agreements. As you say, there is a level of trust and legal enforcement in place where you just have to say you have to agree not to do certain things, because outside of getting into data clean rooms and differential privacy, as I said, there's not a lot you can do to technically prevent people from extracting data from systems like Snowflake if they've got access to a share. Some of the things that you can do technically that are interesting with the cloud, you can make use of things like views. This is reasonably common and straightforward. So you can have a lot of views that restrict what is then shared. So you share the view rather than the underlying data. And using in-place sharing means you can do a lot more of that than you can with kind of older techniques, because the data doesn't need to be duplicated for every view. Right? When you do sharing with something like a CSV file that's extracted, if you want to share different views of the data, you have to extract all the different possible combinations into different sets of CSV files for different consumers. And that obviously then means it uses a lot of resources in compute and storage and so on. Whereas Snowflake or Databricks or BigQuery, you can create a view that is exactly the data that needs to be seen. And you can even use that to apply things like obfuscation or some of the kind of differential privacy you might do where you exchange things like tokens. So one of the things that we see some people do is two-way sharing, where I share with you an obfuscated token that allows you to identify data that you have that you would then share back with me. So you join on the obfuscated token, and then you share the data back with me of only the rows that match that obfuscated token. It gets a little technical, but it means that we can say, where we have data related to the same things, we can ensure that we share the join of those data without necessarily sharing the details of what we know about each of those individuals. So there are some things that can be done there, but at the limit, you get into clean rooms, right? Once you get beyond your confidence to operate with another business based on kind of contractual agreement and a legal framework that's in place, you get into the more realm of clean rooms, which are fully controlled environments, and they're often maintained by the provider of the data. And with the clean room solution, it's a little bit different from most of what we do, where you're actually saying we've set up this environment, you log into it, and you have very controlled access of what you can do in that environment and whether you can extract data out of it.
And in terms of the work that you're doing at Bobsled and some of the specific problem areas that you're trying to solve for, what is the kind of unique set of capabilities that you're enabling that aren't present in these other platforms, or some of the ways that you are approaching the problem that is maybe vendor agnostic or removes the constraint of everybody having to use the same technology platform?
Yeah, the largest problem that people face, the largest problem, challenge, and shortcoming that people face using in-place kind of cloud native sharing is that requirement that the recipient, right, who's receiving data and the person who's sharing it both have to be using the same cloud and platform. In almost all cases, you have to be on the same kind of cloud platform and region. So we talked about things like Snowflake, who are a real leader here, but Snowflake sharing is only truly straightforward if we're both in the same Snowflake region on the same platform. So we're both in US East 1 on AWS. If you're in Snowflake but you're using Snowflake on GCP, in EU Central, it is possible, but you then have to do database replication with Snowflake, and it's no longer I want to share this table to you. It's actually a whole process where you have to replicate the database and then do a share in a different region. So even within the same platform, there are challenges, but the major challenge and shortcoming is for cloud native in-place sharing is that we have to agree on a platform that we're going to use, and that's extremely difficult in practice, right? It's always never practical if you're the person providing an analytical data set to relocate your data operation into another cloud. And data is often the result of a whole process of what's done to collect that data and store that data, and it's tied up with other things and analysis you have in place. So you don't just relocate your data onto Azure because you've got someone who wants to share it on Azure. And it's almost never particularly practical for a recipient of data to relocate their usage. Because we said it's very rare for data to be used in isolation. You want to join it on other data you have and feed it into your existing processes, whether they're analytical or transactional. So you're not going to relocate your application to a different platform just to receive some data that's being shared to you. So in this kind of many-to-many environment where it's really high cardinality, particularly when you take into account the cloud and region. Like you could be on Snowflake, you could be on Databricks, you could be on BigQuery, and then like you could easily be in different regions in the same platform. There's this huge limitation that just isn't solved for you unless someone makes a move to a different cloud platform. And that's one of the massive things that we're solving for in Bobsled. So our aim is to provide that really simple, straightforward experience where you say, I want to share these specific views or tables or this specific data from my object storage to this person. And with Bobsled, you say, this is where I want to share it to. Right? And so you can say, I want to share it to Databricks. I want to share it to BigQuery. I want to share it to Azure Blob Storage. And what the recipient experiences with Bobsled is they just experience that same straightforward share in the cloud native way of the platform that they're on. And what the provider experiences is that we either access their data directly or we access their data via simple share. And we solve the problem of like, how does the data move from one place to the other? And how do we maintain efficient sharing if you're doing sharing to multiple people in the same destination and region without doing things like replicating all of your data? So yeah, this allows people to maintain that kind of shift left of simplicity, taking responsibility for structuring their data, making it analytics ready and usable, with the ability to straightforwardly share it to someone else without anyone having to think about all the ETL and so on that's involved. And that's what Bobsled does under the hood.
And then another challenge to this data sharing question that we touched on a little bit, but is that question of auditability and governance when you are sending data to another entity, because at a certain point, there's no way for you to maintain control anymore, because once somebody has access to the data, even if you want them to be analyzing it in situ, there's always the possibility that they're going to extract it and do some other thing with it. And I'm wondering how that factors into the ways that the socio-technical aspect comes into play with some of the sharing agreements and some of the regulation and compliance aspects of doing data sharing, particularly when you're dealing with something like healthcare data and you're maybe a medical provider sharing patient data with a medical researcher for being able to develop some new sort of therapy, et cetera, and some of the ways that the sharing protocol maybe can and should incorporate that audit and access control and governance enforcement in the process of that access and sharing.
Say a lot of it comes down to the agreements and but what the protocol can do is help to make people very clear and have a shared understanding of agreements. So, for example, with something like right to be forgotten, we can help people to standardize on the way that they communicate things that need to be deleted. So if we are both signed up and compliant to the European data processing rules around that, if one of my, and you're a sub-processor for my data, if I pass on a right to be forgotten request to you, you need to process that and delete the relevant data. And that's a contractual arrangement between us. When we get into the protocol level, you get into practical questions of like, well, okay, well, how do we do that? How do we communicate to you the information so that we can be reasonably confident that we've given it to you and that you know what to do with it and that you then process the deletes? And there are some interesting challenges with that particular thing of how do you keep track of the fact that you have deleted something and also that you have deleted it, right? And you have to keep track of like, we know that we did delete this and can prove we deleted it, but we don't actually have the data because we deleted it. And so things we can do is help people to standardize around, how they communicate and share that data, and things like whether that's something that people also want to sign up to with an API. It's like, maybe don't just want, here are the kind of token identifiers of things you need to delete and they're in a table, but there's also an API call that you can do to process that, to trigger that. And we also talk about like sharing being more rich than just the data. So some of the things that you can share in data warehouse platforms are things like user-defined functions, stored procedures, native apps, and things like that. So there you can help people to share a function that can do things like carry out a delete of a particular entity. And you can say, did you run this function and generate the output? And two-way sharing can be something that people can use as part of a compliance process to say, can you share back to us either data or something that's computed over the data, like a checksum? Right? So, okay, can you provide us some kind of receipt that shows that you've carried out certain actions by sharing data back? Right? And again, that's something where we can really help by providing this ability to say, go from Snowflake to Databricks and Databricks back again to Snowflake means that each person can be operating where they have the confidence and the expertise, but you can provide a flow that means that you can provide some receipts. And we also do abstractions over things like the telemetry and the audits. So we can say, as a person who's sharing data to someone else, you can go into Bobsled and get your audit logs of the access to that data as far as it's available, depending on the destination platform, but you can get that as this kind of single Bobsled abstraction. You don't have to be spelunking the audit logs of 4 or 5 different platforms if you need to kind of verify something, some question around like who's accessed the data and so on. Part of our kind of plans, although it's not yet something we do as well, is communicating governance rules and requirements. As we talked about, one thing is that you have to agree, contractually and say we're going to abide by some rules around how we're going to process this data. And if you're subject to something like HIPAA, I will know that you get audited. Right? We're ISO 27001 and SOC 2. We're working towards HIPAA compliance. So if I'm HIPAA compliant organization and you're HIPAA compliant, although I can't audit you directly and say, look at what you've done, I can have confidence that you are audited. And one thing that we're looking at is providing a way for people to say what their kind of governance requirements are and have that clearly passed along with the data so that the recipients of the data clearly can see these are the governance requirements of this and that they've attested and said, like, yes, we meet those requirements, and helping to kind of make that part of the data sharing protocol and tying it up with that business socio-technical system.
And at what point do point-to-point connections for data sharing reach the limitation and you need to then step into the situation of having a data brokerage for escrowing certain data sets that multiple organizations need to be able to have access to? And what are some of the ways that the data sharing protocols can maybe also help to reduce friction of populating those data sets and consuming those data sets?
Yeah, so one of the things we do is we kind of combine hopefully what is the best of the in-place sharing with doing some of the work of moving data around and achieving efficiency. So I talked about when you have a kind of shift right approach, every consumer of the data has their own copy of the data and their own compute doing ETL and so on. When we do a data share from like one platform to another, some ETL has to happen, right? Obviously, like in-place sharing requires the data to be in place. So if you want it in place shared in Google Cloud, it's got to be in Google Cloud. And if you want it in place shared in Snowflake, it's got to be in place in Snowflake. And if you want both at once, you have to have 2 copies of data. But what we can do is make sure that if you're sharing the same data to 10 people in AWS US East 1, that there is only 1 copy of the data in AWS US East 1, and all of those 10 people are then consuming a view on that data. So we can ensure that you're getting the best possible efficiency of what's being shared. And as we think about things like access and things so on as well, like we can provide, what we do provide is a very simple way for people to do things like revoke access. As you start to think about the challenges that people face trying to achieve data sharing into multiple clouds, multiple platforms, just if you want to say, okay, we want to revoke access from someone now, the work that is involved with that can be quite significant, right? You have to go into each platform and where data might be being used and individually figure out how to revoke access in that particular platform to that particular person. So with Bobsled, you can just go into Bobsled and say revoke access, and we'll make sure that that particular person loses access. And where you've got multiple people sharing from the same data set, you've got 10 consumers in one particular region, we can handle things like the kind of garbage collection and reference counting. So we say, we'll maintain that data in that location until it's not being used by anyone in that location. And then it doesn't need to be updated. And there's obviously a number of technical challenges in terms of orchestration and permissions management and things like that for us to do. You mentioned kind of escrow as well. Escrow there's some different understandings of that. And it is a use case that we've talked to various people about. At the moment, one of our approaches there has been to say we can help to ensure that data is available in different places and synchronized. But often if you want to kind of escrow data against certain conditions, the best thing to do is to use cryptography and then manage the cryptography keys. Right, so we can say we can share the encrypted data between a bunch of places. The place where I've experienced this personally is around source code escrow. So when you're a startup working with some enterprises, they'll say, if you go bankrupt or out of business or stop service in some way, we'd like to have the possibility that we could maybe continue to operate the service. So you need to put your source code in escrow. And there are some companies who provide that kind of thing as a service, but you can also do this sort of DIY thing where you're saying if you want a large amount of data in an escrow, you can encrypt it. Bobsled can help you then move that data around, but the escrow process can just focus on the keys, right, which is a small piece of data, and you can work with law firm and accountancy or one of these people who provide that service to say that we'll hold the keys to that in escrow, and then everyone just has the encrypted data.
In terms of the boundaries that you're crossing with these data transfer technical arrangements, the organizational arrangements, what are some of the typical situations in which you encounter those types of boundaries and the ways that they are defined and delineated? And I imagine most of that is just purely organizational, but what are the cases where technical requirements actually necessitate these data transfer systems versus just being able to do direct integration between them?
Yeah, we see the kind of within an organization boundary, as well as the between organization boundary that you talked about before. So sometimes it can be different regions within an organization. So for a large enterprise, you might have the UK office on one system and the South African office on another system, and sometimes that can be necessitated by things like regional rules or regional availability of services. Another thing we can sometimes see for technical requirements is things like AI processing availability and stuff like that. So people's choices for where they want to analyze their data may not just be driven by the myriad reasons that you choose a cloud or so on, but it might be related to specific AI or blockchain, something we see technical requirements. So if you want to use certain OpenAI things, you maybe need to be on a Microsoft platform. And if you want to use certain blockchain systems, you may be better on another platform or another location. The other one that drives a lot of kind of regional things is compliance and the rules around that, right? So you want to keep data within certain geographical boundaries. One of the things we allow people to do is control which regions and things they allow data to be shared to, right? So you can have data on Bobsled, and Bobsled could make that data possible to be shared with any region, any cloud, any platform. You can limit it down and say, this data is only allowed to be shared within the EU. Could be on any platform, but still on the regions of those platforms that are EU based. So we see boundaries that are kind of geographical and regulatory around that. And there are regulatory boundaries in the cloud. So you have kind of GovCloud services, and in some cases healthcare cloud. Snowflake has a separate Snowflake cloud for healthcare data. So there's obviously some compliance boundaries there. I'm trying to just think through what other things we've seen that might come into this. There are not cloud to cloud boundaries. This is something that we're aware of and keep in mind for the future, where you have a real asymmetry between organizations. So you maybe have quite a small organization working with a very large, a small organization with limited capacity to do sophisticated things, working with a large organization that wants to do very sophisticated things or can do very sophisticated things. That creates a kind of technical boundary of what kinds of solutions and things might be used. And your small organization might want to be using something like Google Sheets. And it's not something we support today, but it is something that BigQuery can do, is to say something like, I'd like to share from a Google Sheet into BigQuery and thence from BigQuery into using Bobsled into anywhere. So yeah, we can see those kind of things where someone says, I want to go from really a kind of different kind of system. We talk about sharing between cloud data warehouses and stuff, but someone might say, I want to share data from a very different system into or out of cloud data warehouse.
And in your experience of working in this space of data sharing and the socio-technical aspects that come into play, what are some of the most interesting or innovative or unexpected applications of that protocol and capability that you've seen?
There are a really interesting thing we've seen from customers is auto fulfillment from CRM. So we allow driving all of this through a single API. So you can call Bobsled API and set up a share or a transfer or make a change. And we've seen really innovative stuff from customers where they kind of directly connecting a CRM into Bobsled. So you do some activities in your system, something like Salesforce or so on, and like Salesforce can send information and so on directly into Bobsled. Bobsled can do a share. Bobsled can make webhook notifications back to your CRM, and you can actually achieve auto fulfillment of salesperson or account manager using the system that they're familiar with, having a data share be created in action, and actually getting updates back in their CRM without the person never leaving the CRM, and without the company using it, really building kind of bespoke software in the sense that they don't have to run some separate software and some separate servers. They're able to build it into the extensibility of a platform like Salesforce, which is really cool to see that people are able to get these things up and running without using our API, without having to build their own server and their own major development process. Another thing that I think is very cool that we do internally is we do Bobsled to Bobsled. So we can send data from one place in Bobsled to another place, and then use that data destination as a source for further onward bobsledding. We use that internally, including doing things like something we're developing is using that to share data back to our customers about things like their usage, right? So if you want to get data about your usage of Bobsled, we're working on providing that as a Bobsled share that you can then consume in BigQuery or in Snowflake or so on. Another thing that we've seen is people do is having data they've got as a source that's something like a CSV. We support loading CSVs into data warehouses. So they use Bobsled to load data from that they've got in CSVs into Snowflake or Databricks or BigQuery. They then set that Snowflake or Databricks or BigQuery up as a Bobsled source, and then they use the capabilities of Snowflake to make views and so on over what they previously had as CSV, and then they use that Snowflake as a Bobsled source to then do further on-stream sharing. So they're actually using Bobsled to kind of do an ETL process and bootstrap themselves from a kind of not cloud native sharing protocol world into a cloud native sharing protocol world by using Bobsled to bootstrap into Snowflake and then onward sharing using Bobsled from that Snowflake.
And in your experience of building Bobsled, working closely in this context of organizational data sharing, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
There's always a lot of challenging lessons from operating as a startup. As I said when we started the call, as a founder, you're often dealing with whatever the most serious problem in the business is at any given time. Yeah, so one of the biggest challenges we've seen is the complexity of building an abstraction over all of these different cloud systems. So I was talking with Jake, who's my co-founder, and we were observing that Bobsled as a product is kind of a simple concept, right? It's one of the simplest concepts that either of us have worked on in our careers in certain ways. So compared to something like a graph database, conceptually a graph database is a really complex thing, whereas Bobsled is a very straightforward product proposition, right? You can share data from your cloud storage or your data warehouse to another cloud storage or data warehouse. And what we've seen is a real challenge between the simplicity of the concept and the challenge of building an abstraction over all the different clouds and warehouses and platforms. And one of the things for me here is that we don't own this kind of stack all the way down. So what we have to work with aren't kind of the theoretical limitations that you might have when using like building Raft. Right? So if you're building a Raft system, you can go and read the kind of PhD papers and so on related to it, and you can understand there are constraints and there's cap theorem and there's the kind of speed of light. And you basically then are kind of up against those challenges. You can try and build a system against that, and you can control it and understand it. We don't have that kind of deep tech or hard tech challenge. There's not at our core like a really hard challenging AI problem or a challenging kind of cap theorem distributed systems problem or something that we're solving for people in a really smart way. What we're challenged with is all of these different abstractions that are present in Azure, Databricks, Snowflake, BigQuery, and they superficially are quite similar. But as you get into trying to manage and work with all of them, you discover that they are different. And the devil of data engineering lies in these details. And so, that's been a really, not entirely unexpected challenge, but that's been where we've discovered a lot of challenges actually to build an abstraction, even across object storage. We find that in AWS, you have this access points abstraction, which is really great, but it's not present in the other clouds. So you build something on AWS and then you realize you can't really build a comparable abstraction for Google Cloud Storage. So you have to do something slightly different. As we get into things like executing serverless functions to do our workload, we execute serverless functions to do work in AWS, GCP, and Azure. And so we had to build out an abstraction for managing serverless functions running on different clouds. And that's kind of challenge that in itself, some organizations have as like their main organizational challenge. So if you're like serverless platform, you're building a technology that allows people to do that. That's just one of the problems that we actually have to solve internally so that we can say, okay, to do object storage sharing between all the different clouds, we need an abstraction that means we can run some serverless compute, means we can make some certain assumptions about how data is stored, and we can make some straightforward ways of saying like how we grant or revoke access to a share. Each of those ends up being surprisingly different and nuanced between different platforms.
And for people who are exploring the problem space of being able to send data from one system to another, whether that's across organizational boundaries or across technical boundaries, what are the cases where Bobsled is the wrong choice, or what are the cases where they should just reconsider the entire application and avoid data sharing entirely?
I think the biggest time when Bobsled is the wrong choice is kind of when either, as you say, perhaps you just don't need to. I'm a huge fan of identifying we don't need to do things, and you can often find yourself in a situation where you feel like you need to do something because that's how it's done, that's how other people do it, and things like that. But a bit of analysis can say, oh, maybe we don't. But one of the major cases where Bobsled is the wrong choice is when something like a data clean room is the right choice, right? So that's when the reassurances you want around like what's visible to someone and what's done with the data and whether or not it can have been extracted and so on. So stringent that you need to make use of something like data clean room. And there's some really cool technologies in that space around, say, things like differential privacy and things where you can have systems that allow you to make kind of aggregate queries that don't reveal the underlying data, but allow you to query the data in the aggregate and things like that. And for a lot of those, Bobsled is the wrong choice or would have to be part of a much more complicated solution architecture. At the moment, we talk to people who occasionally want to do a migration. They want to migrate from GCP to AWS. Their entire data. And they say, well, that's something Bobsled can do. Bobsled can move data from a data store in one place to another. Can we use Bobsled for migration? At the moment, that's something where we would generally say, Bobsled's not the right choice. If you're doing exactly one place to exactly another place, there's probably already a tool in the destination that's good enough for what you want to achieve, right? So if it's Azure Data Factory or something, right? If you're just concerned with getting data into just one platform, then you can probably use the native tooling on that platform. And we're huge advocates of use the native tooling, right? Use the native sharing protocol and this thing, like don't build extra stuff. Yeah, and then I was trying to think of solutions of any situations where we've come across where we've sort of said, do you even need to do data sharing? Like perhaps you should reconsider. I think there are cases where we have the reverse that's true, where you might be like, should this be an API? And so I talked to you about like there are situations where people like we have a JSON REST API hammer, so we're going to solve everything with a REST API. It's JSON over HTTP. There can be an inverse case where you can say, should this use case be something that you're managing with analytic data sharing, or should it be something that's actually an API or a webhook or something else that's like a pub sub notification, right? Another way you can do cross-organizational kind of synchronization in some of the clouds is using things like a pub sub stream where you can do cross-organizational like listeners on pub sub or SNS or things like that. So yeah, sometimes there are other cloud native cross-organizational technologies that might be better suited.
And as you continue to build and iterate on the Bobsled product and explore the overall space of data sharing, what are some of the things you have planned for the near to medium term, or any particular projects or problem areas you're excited to explore?
So I might give two answers to this, but yeah, one thing I'm really excited about or kind of passionate about is tackling something that we call like modern data stack fatigue. So you've probably seen, familiar with there's a whole raft of technologies that go into the modern data stack. I have a controversial relationship with Kubernetes, and Kubernetes has this kind of poster, which is quite cliche at this point, showing you like all of the Kubernetes stack technologies. I don't know if you're familiar with it, but it's incredibly dense. It's like unreadable unless your screen is 6 foot wide kind of thing. And the modern data stack is going in a similar direction, where there's like thousands and thousands of separate tools for doing each like different individual thing that you might do. And yeah, we for the like past decade, like in the world of data and data engineering and analytics, we've had a kind of explosion of all of these different tools and technologies and services and as an infrastructure service and platform as service and everything else. And now we're in a situation where there's fatigue from sort of, I on my team kind of imaginary protagonist is like, well, I have to use like 6 or 7 different technologies. And then when you get into things like hiring, you're suddenly like, well, our stack is this particular combination. When you're hiring, you're like, we want to hire someone who has this exact combination of experience. And you're like, well, that person doesn't exist because there are so many different combinations of possible things that like no one has used your exact combination. And, we're in a macroeconomic environment where there isn't necessarily a budget for everyone to have every single tool, right? And people are a bit more focused on what you can do being lean. And like, do you need to have a bunch of services running for this? We think something like DuckDB is really cool, right? DuckDB has this kind of minimalist approach, which says, you don't need to have a bunch of servers necessarily running, and like you can do huge amounts of analytics on your M3 laptop. And like the thing that's really exciting for us is that we can kind of help people approach some of that, because we don't have a kind of horse in any of these races, right? And within that fatigue, there are sort of different philosophical holy wars, the kind of Emacs versus Vim type of things, where it's like, should you have a lake house or a warehouse or this and that? We can help people to do data sharing kind of regardless of where they stand or what technology choices they've made. And our aim here is to kind of help people achieve simplicity rather than in the face of all of this complexity of options. And yeah, I'm really excited to see what we can do to cover more of these bases and help people to actually have a simpler experience, and incorporating things like DuckDB and things into Bobsled to see there are use cases where people can analyze data potentially kind of directly in Bobsled, right? It's like, we talked about you might need to move the data in place into Google Cloud so you can analyze it with your BigQuery. One of the things that I think would be very cool is, do you need to move the data into the destination cloud to analyze it with BigQuery, or can you kind of issue a query directly using something like DuckDB on the source data, and we never need to do the ETL part, right? Can we help people to shortcut and simplify some of their work? Yes, that's one of the things that I'm excited about. I'm also excited about things like two-way sharing. As I talked about, there's various different use cases, and they're all quite interesting, where people say, I want to share something to you, and then you would do, for example, enrich it, right? So you'd attach it to some data you have, or you perform some analysis or processing or so on of that data, and then you kind of send something back to me that is meaningfully transformed or enriched. So that's one of the things that I'm looking forward to us getting into, because it starts to unlock higher levels of value for people and enable them to collaborate. And as I talked about at the beginning, we can help the industry in a way to do things more efficiently. We talked about like you end up duplicating data if you have data being copied from one place to another and then processed and so on. Helping the industry to be efficient, but also to achieve higher value, right? So it's, for us, sharing is part of a collaboration process. And if we can do two-way sharing, we can help to unlock higher value collaboration. And it's really one of the things that was one of our kind of founding convictions, is that enabling collaboration between organizations is kind of a net beneficial thing. It helps improve efficiency, it helps organizations make better decisions, and those things are broadly in the interests of customers and consumers and users of those services.
And are there any other aspects of the overall space of data sharing, both the technical aspects, the organizational challenges, the ways that you're approaching it at Bobsled that we didn't discuss yet that you'd like to cover before we close out the show?
I think there's stuff I love talking about around this like shift left and shift right mentality, and like who has the responsibility for doing things. So we talked about in kind of data industry, shift left is something that we talk about as being a broadly good thing. It's this idea of moving some of the responsibility and the work closer to the kind of source of the data, right? And saying like, let's help the person who's the source of data. And this is often used inside an organization. We say, should we shift left to a kind of data team in the organization and have a central team who's ensuring that data is clean, that is well set up, that it's easy to query, that it's optimized with stuff like indexes and applications. And And that drives efficiency compared with the shift right mentality where you say, we just provide data and all the consumers have to figure out how they're going to use it and how they're going to compute over it and so on. And what we see, one of the things we can help facilitate is not so much within an organization where you're generally on one platform, across organizations and within those more complex organizations that do have boundaries, is a furtherance of that shift left approach where you say the people who are best placed to structure the data and set up optimizations and generally manage the ongoing life of the data, right, and evolution of the schema and appending of new data and all those challenges that really make up a lot of the work of data engineering analytics. All the kind of the nitty gritty stuff like, oh no, what happens when a stock price splits, or when a country changes its zip codes or something like that. The curveballs that you have to deal with when you're managing data schema. We can help that to be centralized, which is more efficient, more effective, and robust within data sharing between organizations. And this idea of then we can help shift left and we can help reduce ETL, which is two of the major pain points of a lot of data engineering. Is I spend so much time on ETL before I get into my analysis, or I spend so much time on data cleaning and processing and so on before I actually get into my analysis. I think the work that we do can really help to tackle those for a range of organizations in what is a really challenging realm where, for a lot of people we work with, the alternative is kind of some major DIY project. The typical alternative to Bobsled is try and build some subset of this functionality yourself, or try and persuade a commercial partner to make some pretty significant decision like working and doing analysis on a different cloud.
Absolutely. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
That's an interesting question in the context of the modern data stack. I feel like we have a huge range of tools, and in some ways a lot of my passion is about reducing that and simplifying that. So I have some experience in the AI space, and obviously that's extremely hot and very busy right now. I think that I'm not an expert in this area, but one thing that I think there isn't is a really good approach to vector database and embeddings, right? So there's obviously a lot of people attempting to build out good solutions around vector databases and managing embeddings. I've spoken to quite a lot of startup kind of founders and founding engineers based on my previous experiences who are trying to do things like similarity search and KNN and Levensheim distance and all these kind of fairly standard data analytics things over vectors that are being produced from kind of AI processes and large language models and deep neural networks doing computer vision. And that is an area where I spoke to a lot of people about what they're doing to challenge it, and most of the existing tools that are all very new are very pricey or very inefficient above kind of very small toy projects. And a lot of people I spoke to there are running into the challenges and building their own. And that's often where they're talking to me is around the data infrastructure management. How do we manage the infrastructure and build our own thing on top of something like Spark to start running these algorithms at scale over vectors? So I guess maybe it's a kind of obvious or startup founder answer, but I think kind of AI and vector database solutions is somewhere I think there isn't yet a really good mature tool.
All right. Well, thank you very much for taking the time today to join me and share your experiences of working in this space of data transfer and enabling that for different organizations, making that a simpler problem to solve. So I appreciate all the time and energy that you and your team are putting into that, and I hope you enjoy the rest of your day.
Thanks very much, Tobias. It's been a pleasure.
Thank you for listening. Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.